activity of the observer and the body which is being observed. Definition of motion. A body is said to be in motion when its position is changing continuously with time relative to an observer. Note: let us perform an activity for drawing path and distinguishing between distance and displacement. Click each tab to know more. Take a circular object like a ball. Throw it into the air with some angle to the horizontal. Observe its path and draw it on paper. We observed the path taken by the circular object when it was thrown into air and the length of the path traversed by the object. In this activity, we learned that the length of the path traversed by an object in a given time interval is called distance, and the shortest distance covered by the object in a specified direction is called displacement. To describe a physical situation, some quantities are specified with magnitude as well as direction. Such a physical quantity is called a vector. The physical quantity which does not require any direction for its explanation is called scalar. Here, PSQ shows the actual distance covered by an object and PQ is displacement, which is a straight line drawn from initial position to final position of the object's motion. The physical quantity which has magnitude and direction is known as vector, and the physical quantity which has magnitude and do not have direction is known as scalar. Therefore, we conclude that the distance is a scalar and displacement is a vector. The SI unit of the distance or displacement is meter and is denoted by m. In the same way, kilometer, centimeter, etc. are also used to express this quantity. Because 1 kilometer is equal to 1000 meter, 1 meter is equal to 100 centimeters. Drawing displacement vectors. Consider a person standing at point P and moves x kilometers towards point Q located in east along PQ, and then after reaching at point Q, he starts moving along QR a distance equal to y kilometers due north. The actual length of the path traveled by the person to reach point R is the length of PQ plus the length of QR. So, x plus y kilometers is the distance traveled by him. Already we know that distance is scalar quantity and its value can never be zero or negative during the motion of the body. In the same example, join the point P and R to know shortest distance. The length of the straight line PR is the displacement from P to R. Thus, the displacement represents the shortest straight line path between the initial and the final positions. Here, the displacement can be found by using the Pythagorean theorem or hypotenuse theorem. Displacement is a vector quantity and it can be positive or negative or zero. Note: the distance covered and the displacement are time-dependent quantities. Suppose a person again travels from R to P, comes back to the original position. Then the person has zero displacement even though he was moved through a distance. Because the person moves back to his original position, that his final position coincides with the initial position. Let us consider the real-time example to understand the average speed and average velocity. Suppose a bus started at point A and reached point B, which is at a distance of 450 kilometers in 9 hours. Here, the distance covered by the bus in each hour is equal to 450 kilometers per 9 hours, which is equal to 50 kilometers per hour. But the bus does not cover exactly 50 kilometers in each hour, because there may be some variations in distance covered by bus for each hour. So we take average of distances covered by the bus for each hour to decide its average speed. The distance covered by an object in a unit time is called average speed. Let the displacement of the trip in this example be 270 kilometers due southeast. The displacement in each hour is equal to 270 kilometers per 9 hours, which is equal to 30 kilometers per hour. The displacement of an object per unit time is called average velocity. Average velocity is vector and is along the direction of displacement. The quantities average speed and average velocity explain the motion of a body in a given time interval. They do not give any information about the motion of the body at a particular instant of time. Numerical problems. Vinay swims in a 60-meter long pool. He covers 120 meters in 1 minute by swimming from one end to the other and back along the same straight path. Find the average speed and average velocity of Vinay. Click the tab to view the solution. Instantaneous speed. For example, we can tell the speed of the bike at any instance by looking at its speedometer. The speed at any instant is called instantaneous speed. Definition. If the speed of a body changes continuously with time at any instance is called instantaneous speed. The instantaneous speed at a given point is equal to the ratio between sufficiently small distances over a part of the path which contain the reference point and the corresponding small time interval. Speed and velocity. Every object in motion has both velocity and speed. Consider a car moving along a straight road with varying speeds. The motion of the object can be described using distance versus time graph. In this graph, time is taken along the x-axis and distance is taken along the y-axis. From the graph, it can be observed that in time interval t1 to t2, the car traveled a distance equal to s2 minus s1. Then the average speed of the car is s2 minus s1 by t2 minus t1. Speed gives the idea of how fast the body moves. In general, bodies move in a particular direction at an instant of interest, and this direction may not be constant throughout the journey. So, we need to define another quantity called velocity. Velocity gives the idea of how fast the body moves in a specified direction. So, it is a vector.